Decoding of National Electric Code of India 2023. I would like to invite on stage Mr. S. Gopakumar, Srimati Preeti Bhatnagar, Mr. Narendra Dwivedi, and Mr. Krish Theobald. It's my pleasure to quickly introduce our panel moderator and panel members. Mr. S. Gopakumar, who is the panel moderator today. He is the president of National Federation of Engineers for Electrical Safety. He is an electrical engineer and a founder and promoter of Cape Electric Private Limited, Cape Electric Power Production Private Limited, Obo Betterman India Private Limited, LP Consultants International Private Limited, and currently the president of National Federation of Engineers for Electrical Safety. He is a member in the technical committees of BIS, various electrotechnical committees, and also the committee member of National Building Code 2016. He is also member of various working groups of IEC. Then we have our panel member, Srimati Preeti Bhatnagar, who is head ETD retired, Bureau of Indian Standards. Srimati Preeti Bhatnagar is an electrical engineer by profession and has been working in BIS since more than 30 years. She has worked in different activities of BIS, which includes standard formulation, certification, and training. The major part of her tenure in BIS was dedicated to the certification activity. Mr. Narendra Dwivedi, our panel member, is Executive Director of SS Powertech Private Limited. He has done his BE Electrical Engineering from College of Engineering, Pune, with specialization in power electronics and power systems. He also holds other certifications like Bureau of Energy Efficiency, Certified Energy Auditor 2009, BVQI Certified Lead Auditor for ISO 50001, Chartered Engineer, etc. He currently holds position like Executive Director, SS Powertech Private Limited. He is immediate past President, Consulting Electrical Engineers Association of Maharashtra, CWC member, Mumbai chapter, National Federation of Engineers for Electrical Safety. Mr. Dwivedi brings with him 42 years of field experience in electrical and power electronics industry. We have Mr. Krish Theobald, Technical Director and Principal Consultant, Protigo Plus Electrotech Private Limited. Mr. Krish is a meticulous electrical designer whose passion is electrical safety. His expertise lies in LV electrical installation design for commercial and large-scale domestic installations. His specialization is achieving on-the-ground compliance with IEC 60364 based on national wiring regulation. He is also a member of Electrotechnical Committee 20 and 50 of BIS. He is also trainer of BIS's capsule course on National Electricity Code of India. So we'll start with the panel discussion, and over to you, Mr. Gopakumar.
Hello. Good morning, everybody. I hope my sound is clear enough to listen. So we have been given a tough task by IEEMA, the organizers, to conduct a talk on NEC. Initially, they gave 1 hour, 60 minutes. Then I could see that the time started, reducing 55. They started reducing the time. Anyway, we will try to cover as quick as possible and as fast as possible. So our subject, can we see the slide, please? Oh, sorry, not this one. The panel meeting. I gave another slide, another presentation, the panel discussion. So today we are going to, the panel discussion is mainly on National Electrical Code of India, which was published in January 6th, 2023. Also, we will be discussing a little bit about CEA electricity, the regulations of Government of India, as well as the CPWD manual, which was published during 27th of June. Also, one more standard which was published very recently, IS 18732, which is which is a guide, explains how to use Indian standards and regulations while constructing or in a project. So, all these, the new documents are going to take us towards net zero. With respect to safety, I am sure all of you know the situation of electrical safety in our country. Accidents everywhere, average 14,000 people die due to electric shock alone, which is about 723 people out of 100 million population per year. These data are available in comparison to our 723. Japan has got 12 electrocution death per year. And India, one interesting subject is only 50%, all the accidents are not reported. Out of the reported incidents, about 50% are in consumer premise, within the consumer premise, and about 48% are in the low voltage or up to 33 kV distribution. About 2% happens on the high voltage, extra high voltage. So you can understand where we stand. You see, yesterday when we came, once when we look at finalized the venue, and once when IEEMA told that this time the program will be in Goa, very nice venue, Taj Hotel, one of the best hotel. So I was so happy to be here. And then in the evening I went to the room. The room was very good, clean, big room. Then I could see that just under this bed, something hanging. You can see here. You see that? The best hotel, the biggest hotel, and the safest hotel. And we talk about electrical safety and we talk about fire. There is a light fitting just under the bed, and you know how bed can catch fire. And this is hanging. The whole thing is, if I put my hand, I get shocked. And come on, we talk about electrical safety in the venue, and we are conducting a program on electrical safety, and this is the situation. I actually invited somebody from the electrical engineer from Taj Hotel to be here. I don't know whether he has come or not, but gentlemen, you should rectify these mistakes, please. Otherwise, you will be in trouble. Similarly, if you look at the gentleman who is sitting on the camera, just under him, next, on the left side, you see there is a 2-pin plug and socket. There is no earth connection. So, actually, once when we look at electrical system, we always see funny installation. Always funny installation. Safety is a subject which we never, it's not in our blood. We have to accept that safety is not there in our blood. And what we talk? We talk about economics, economical, reducing the cost. We have to have, we have to increase our production and reduce the cost of our electrical system. But we never try to understand that what value we add to this. This photo is from a 5-star hotel, again in Delhi. On the left side, it's an automation system. Probably the cost of the room automation is a few lakhs of rupees. And you look at the way it is installed, and we should think, what value are we adding to this whole installation? For the whole life of this installation, it's a mess, and the customer has to run behind it. In Europe and America, manufacturers train the electricians to install those products. Whereas in India, this culture is yet to start. We have to start it. And now let us look at what is the electrical safety legal requirements in India. At the top of the first legal requirement is the Electricity Act set in the Parliament, which is called as the Electricity Act. Under the Electricity Act, Section 53 or 177, we have the regulation, measures relating to safety and electric supply regulation 2023. This regulation was published on 8th of June 2023. Then we have the NEC, which is published on January. Then we have a lot of new standards. So basically, this is the hierarchy of electrical safety scenario in our nation. Now, some interesting subject I wanted to take you. Section 146 of the Electricity Act says, if you are not following the rules and regulations, the responsible person can be put in jail. So there is a penalty clause, you can be put in jail, and Section 149 explains about who is responsible. If you look at read the Section 149, I'm not showing in the screen, Section 149 says that the owner of the property is responsible. Basically, for this electrical safety, we have even tested some of the sockets. If we look through the legal system, even the general manager of the hotel can be held, guilty because safety is missing. Sorry for that. Now, if you look at, for the first time in our history, Section 14 of the regulation made National Electrical Code and National Building Code mandatory in the country. This is for the first time in our 75 years history. Until now, standards were a recommendation. It was may be followed, but now the wording is shall be followed. This is a big change which came in the regulation. I will just take you to one of the regulation. For example, regulation number 38, which is talking about, you can see the sub-regulation number 3, which talks about high-rise buildings, buildings more than 15 meters height, or buildings such as hotels, hospitals, airports, public buildings. Actually, it is irrespective of height. There, these special rules apply. For example, it should follow the NEC as well as all the standards. Then the wires, you can see some special wires are necessary for these buildings. Lightning protection shall be there. Verification of the electrical installation shall be made as per the standard. These are actually new additions in the standard or in the regulation, which is going to be implemented very soon, because rules are there, but who is going to implement is also the next question where Madam will answer. Now we have the NEC. 2023, we were working on this quite some time. You can see NEC, the first edition, I'm going a little bit quick because I can see in front of me, the clock is also running very fast. So, the first edition of NEC came in 1985, the second edition in 2011, and the third one in 2023, which was in January. Please note that NEC is not a product standard. It's an installation standard. Installation standard means it explains how to design, how to select, how to design an electrical installation, how to select the products, how to erect it, and how to verify it. So it's an installation standard, very important for the electrical designers. We have more than 100 experts in the committee, ETD 20 committee, and we were working for almost last few years. It is prepared by ETD 20 committee. Madam was heading ETD during this whole time. We have about, the whole NEC has got 8 sections, starting with the general and common aspects, which consists of 22 sections. The whole book is about 747 pages. Part 2 talks about generating stations and captive substations. Part 3 about electrical installation in special location. Part 4 in industrial building. Part 5 outdoor. Part 6 agriculture and horticulture. Part 7 hazardous, and Part 8 solar photovoltaic. These are the 8 sections which is, or 8 parts which is included. Out of this, Part 1 and Part 3 have got multiple sections. For example, Part 1, it consists of 22 sections. Up to Part 8 is generic information. Part 9 talks about the wiring installations. Part 10, 11, 12, 13 talks about the fundamental safety requirements. 17 talks about verification. 18 talk about earthing, and so on. So these are some of the sessions which you can see. 22 sessions. Similarly, Part 3 talks about a special location. This is very important because Part 1, 22 sessions are talking about the safety requirement in a general electrical installation. In a general electrical installation, we have special locations such as bathrooms, such as shower cubicles, or such as medical location in hospital. For your information, we had an NEC 2011. There was a part 4, hospitals. This part was explaining a lot of safety requirements in the medical locations, means group 0, group 1, group 2 medical locations. I have visited at least 75 to 80 hospitals during these years. I am yet to find out a hospital where these safety measures are implemented, or in an operation theater where these safety measures are. The situation is really unfortunate, or it's quite unfortunate. These 22 sessions are talking about special installations. So this is about the content of NEC. Now, we would like to go through some of the, I will give one question each for our panelists to answer. Then we come back to you with questions to you, or you can also ask question. The first question to you, madam. Now we worked very hard, fight with a lot of departments or whatever, then finally the book is out, the regulations are out, how do we implement?
Thank you. Thank you, Gopaji. Good morning to all of you. Here, Gopaji has given a brief about the National Electrical Code and the situation existing in our country with respect to safety of electrical installations. So how we are planning to implement, before that, I would just like to very briefly, we have less time, say why is it required in the first place. You see, BIS is an organization as old as 75 years, established in 1947. We have been bringing about standards for a very long time now. But developing these standards has no meaning if these standards are not used by the relevant people, if they are not put to use in practical life. So what is the point if these standards are gathering dust on the shelf? So this is what is happening. And in case of NEC, it is very, very prominent, very evident. People don't know about a National Electrical Code. To the extent that in one of the awareness programs when we were carrying out, one of the persons, he was very happy to know about the NEC, and he was praising us that BIS did a very good job to bring about such a code today. Then I corrected him. We did not bring this code today. This code has been existing since last 40 years, almost. The first version came in 1985. Second version came in 2011. And this is the third version, 2023. So people were so ignorant to the extent that they were not even aware that this document is existing since past 40 years. So this is the level of unawareness among professionals. I'm not even talking about common person or layman. I'm not talking about them at all, who are the users actually. So, so the need was felt that this time, जैसे हम कहते हैं कि हमने कमर कस लिया कि नहीं, we will do our part. कि जितना भी हम we can make people aware about it. So steps were taken, and the first step, of course, that step is not with respect to NEC. The standards are all indigenous standards are available free of cost. This is with respect to all the standards, because it is not just the NEC which has to be implemented. Every standard brought out by the Bureau of Indian Standards should be put to use. Otherwise, it's of no use. All the standards are important. So the standards, all indigenous standards, recently only about 2 years back, 2-3 years back, we had made it free of cost. They are available on our website, can be downloaded. The indigenous standards, all those standards which are in dwell number with the IEC, they are not free of cost, they are priced publication. But in that also you have an advantage that the original IEC is very expensive, but once we adopt it as a dual number, the cost reduces to a very large extent and becomes affordable. So that's the first step. Then of course we have the BIS Care app. It is a mobile download. It can be downloaded on your mobile. Again, this BIS Care app is not just relevant to NEC. It is for all the standards, and not just the standard. As you people know that we are running a certification scheme also. Through this scheme, we are giving ISI mark to the various products. Third-party guarantee for the quality of the product, that this product is conforming to certain standards. Now these products are available in the market, but there is a lot of duplication, lot of spurious products, a lot of spurious ISA mark is also available in the market. So through this BIS Care app, you can not only have information about the standards, but you can also check the genuinity of the ISA mark. You can put the license number in the app, and you can check the app will tell you whether this is a genuine licensee or not. And if it is not a genuine licensee, if it is a spurious license number, then immediately you can lodge a complaint also through the app, which will reach us, and we will take action on the manufacturer or whoever is the defaulter. So it's a very important app. I think everybody should have it in that mobile. Then apart from that, we are conducting training programs. For the first time, we are conducting training programs on NEC. 2-day training programs. 2 programs have already been held. And in these training programs, the experts are informing the people about the NEC, the provisions covered, some workshops are held. And these have been attended, very well attended, from the various sectors, like the industry, the government people, and the consultants. They have attended, and it is very much in demand, and it is, we have many more programs lined up this financial year. We have also prepared a BIS talk video on NEC. It's a half-an-hour video, and this video was circulated to all. जितने भी हमारे पास email IDs थे, we have sent to everybody through email. It is available on the website, and everybody can have a look at the video, which very nicely and very clearly brings about the need, not just the need of NEC, but what it covers and how to implement it. Then, of course, like Gopaji said, through the CEA regulation, earlier it was only recommendatory. When the draft regulation came to BIS, again it was only recommendatory. Then specifically we approached CEA and we told them, no, you make it mandatory. Unless it is made mandatory, it will not be implemented, it will not be put into use. Everything has to be enforced, unfortunately, here in this country. So they changed it to shall. From the word may, it came to shall. So now it is mandatory through CEA, and we hope that that will make a lot of difference. Then apart from this, we are also holding many awareness programs. We have held several awareness programs in many states. Gopaji is helping us a lot in that, and with the collaboration, and which is very well attended. Around 100, 200 people are attending these programs. And through this, our aim is not just to reach out only to the professionals, but also to reach out to a common man, so that a buyer, a user can tomorrow demand that his building should have electrical installation as per NEC. Because if he says that, then definitely it will be done. So that is our purpose, to percolate to the lowest level. Thank you, sir.
Yeah. So that is about the NEC, but please note that the state governments, the electrical inspectorates started demanding compliance to NEC already. Some of the states started circulars within their department saying that the NEC is made mandatory, you start to ask for this. So the things started changing. We can discuss hundreds of change in NEC with respect to the existing practices, but we don't take up all the subjects here. We have only limited time. I can see only 36 minutes are left out. I'm sure that the organizers will give a little bit more time. But now implementation, please note that very soon, electrical inspectorates will start demanding the compliance to NEC. Very soon. We started that work because if we can put it in the regulation, then why not implement it? This is the question. Second is, insurance companies also will start demanding this particular thing. Third is valuation of asset, because for example, I was coming across a hospital construction recently. When I discussed with the owner of the investor, they told, no, our idea is to sell the hospital. We have to only quickly complete the project and sell it. The idea is not to construct a good hospital, but to sell an asset. So valuation of asset also now NEC will be applicable. It will be, if the compliance is not there, then devaluation also can happen. This already started doing. Some Canadian funds are buying a lot of large scale assets. One of the data center, there was no compliance, then the value of the electrical installation, the whole value was degraded to about 20%. So, things are changing in a different way. Now, some of the subjects which we wanted to take up, part 1, section 17 of NEC talks about verification of an electrical installation, which is actually the last job. Design, selection, erection, verification. Now we have Dwivedi sir with us. He is very much into the verification job for the last few years. We would like to listen, or for all of us, can you please enlighten us about the verification which is happening in the industry?
Okay. This gathering will have to excuse me for my negative thoughts now, because every day when I go to site, we audit about 100 establishments every year, and everywhere it is all negative. Firstly, I would like to say here that apart from what panelists have already said, we Indians are genetically indisciplined. That statement I make on all common platforms, because we love being indisciplined, right from your traffic rules to what we do in electricity as well. A very simple rule one has to follow in electrical engineering as far as all these fire incidences are concerned is about I square T. We all know what is I square T. I square T has to be contained so that your equipment doesn't damage when you don't want it to be damaged. So typically Gopalji's presentation show that 48% accidents happen on LT side. Now LT side, typically your current under short circuit increases by 18 times, and when I ask by O&M people when we do audits, they say heat also will increase by 18 times. Actually it is square of that. So I square T it is, right? So 18 times when your current increases, the heat increases by 300 times. And that has to be disconnected as early as possible, so that otherwise your equipment will damage or it will catch fire. So these two, as far as compliance and verification what he is talking about, I would split it into two parts. One is existing establishments and another is proposed establishments which are under design with all of us. So first part, if we look at, I can give you examples right from a 200 watts LT installation to about 100 megawatt 132 kV industrial establishment also. Most of the places the scene is same. People are absolutely unaware that, when I go to a 22 megawatt station and the main person says that he doesn't know CEA 2023 or CEA 2010, I was just shocked, initially. Now I don't get even that shock also, because I know that same answer I'm going to get everywhere. So first thing is, I think we will have to, for verification, as he is rightly said, it is a last stage. Before that, I feel a verification of design also has to be done. Now, foreign countries, we are working for a county in USA at present, where human-less electrical drawing approval software somebody is developing in India, and we are helping them for decoding NFPA 70E. Now things are happening at this level in the country. We all have seen, impact in GST and income tax. When the assessments have become humanless, things are very easy, and so many people have started following it. Everyday revenue is increasing. So something similar will come in electrical engineering also. It will take time. Till that time, we have to increase the awareness. Otherwise, things are not going to happen in a very easy way. People are absolutely confident about zero regulatory control. Any industry you go, they always say that, we don't bother when the inspector comes and goes and what he has to check and what he doesn't have to check. There is another side also to it. If you take case of Maharashtra has about 40,000 HT consumers. So I predict that in India there will be about 5 lakh HT consumers at least. So 5 to 6 lakhs HT consumers with the infrastructure of electrical inspectorate department which we have here, according to me, physically it is impossible. They cannot check all these establishments once in a year, and they cannot approve each and every installation, every state and every year. So manually, is it possible? It is not possible. So just like Energy Conservation Act, all of us, we decide to do it voluntarily or as a self-compliance, it will be better. For that, I'll give you an example of chartered accountant structure in India. Whenever chartered accountants are there, what happens is 50-60% people follow income tax rules. Something similar can happen here also if we have that kind of a structure here. The problems are severe. Right from workmanship till product quality till so many things. All those problems are existing. I have only one example to tell you. There is a grocery shop or other departmental store shop in Pune, which has about 10 shops. It's a big shop. It has long tradition, about 50-60 years. The owners, make us audit all those 10 shops every year, and their consultant and their contractor accompanies us, and they implement within 15 days whatever we tell. So such people are there in India. It's a Parsi community shop. So I think Parsis are disciplined. So things happen there quite easily. So same thing, if we follow, I think things will be easier. Otherwise, in both cases, problems are there. There is a huge knowledge gap, I would say. Fundamentally, electrical engineering knowledge is lacking with, let me say, lot of designers as well. If not all, there is no definition of an electrical designer in this country as of now. Who can design? Yesterday, people were saying that draftsmen are calling themselves consultants now. Contractors usually call them consultants. Any contractor can say that I'll design, and most of the time real estate developers say that we have to develop and go away. We don't want to, we are not involved in what is happening in those stations those places once we go away. So this is the status. I mean, it is not very encouraging.
Thank you, sir. Thank you, sir. Actually, there are about 18 inspection points which I have shown in the earlier slide. So these are the inspections, 18 inspections, as well as 11 tests, those who are included in the NEC. Now, for your information, if these inspection and tests are made properly, almost 99% of the mistakes in the design as well as selection as well as erection can be found out. There are formats which has to be filled by the person who is doing the audit. Anyway, that is, it is a very big subject, and the government is also trying to implement these measures very soon. Now we have to go to the next subject. We have a lot of, copper wire or the cable companies here. I am just trying to put my leg into their shoes, and I have the young gentleman, Krish, to help me. We will try to explain or try to discuss a little bit about the cables and wires, especially the copper cables which is used in the, or which is recommended in the NEC. So in NEC, Part 1, Section 9 explains in detail the methods of selection of copper wires, its filling factor, derating factor, and so many subjects are there. Now, the most important parameter here is the valuation. The derating factors are based on the heat produced by the conductor, the copper conductor. Heat, it is not the insulation. The primary subject is the resistance of the conductor and the heat produced. In section 17, part 1, section 17, you can see this particular table where the heading says, after pulling the cable or wires through the conduit, resistance of the conduit or resistance of the wire has to be measured, and the maximum resistance shall be lesser than this particular, the resistance which is shown in the particular table. We actually bought few cables here. I would recommend Krish to make a small demonstration and explain what exactly is this subject. Over to you.
Can you put this? Yeah, perfect. Thank you. Can we just show the slides as well? There's a bit of context on it. So thank you. Okay. So just so we get started, as we all know, there's an Indian standard, IS 8130, which is an adoption of IEC 60228. It talks about the various types of conductors. In specifically, we're talking about the stranding. So there is class 1, which is a solid conductor. Then we've got class 2, which is a stranded conductor. We've got class 5, which is a fine stranded conductor. And we've got class 6, which is a very fine stranded conductor. The National Electrical Code of India requires us to use either class 1 or class 2 conductors for fixed wiring. That is either solid or stranded. However, unfortunately, in the market, what is predominantly available is class 5, which is, sorry, is the volume very high? No. It's fine, okay. So what's predominantly available in the market is class 5, which is fine stranded. These have higher resistance values, as a result of which there is more heat dissipated. I'll just show you so basically it also contributes to a higher impedance. Therefore, you are going to see slower disconnection times. When we look at IS 8130 and IEC 60228, they have certain values. Now, I have here a red bundle. This is class 2 conductors, 1.5 square mm, 90 meters. The yellow bundle is class 5 conductors, 90 meters, 1.5 square mm. And I've got the blue bundle, which is a supposedly 1.5 square mm class 5 conductor, 90 meters again. Now we'll just do a little bit of math. I have picked up the values from here. So see, as I said, 60228 is just directly taken into, the values are the same in 8130. They tell us that for class 5, for class 2, we should get 12.1 milliohms per meter as the resistance. 20 degree ambient temperature, max DC resistance, 12.1 milliohms per meter. For class 5, this becomes 13.3. So immediately you see a jump. Safety aside, there's a lot of talk of net zero here. This was almost a 10% increase. So all you have to do is by using by using the correct type of conductors, you can save about 10% of your energy consumption. So that's around net zero. Anyways, so now to actually make my point, we'll actually go ahead with a demonstration. So I've done the math, so we know what to expect. So if we take 12.1 milliohms per meter, we multiply it by 90 meters, and we convert the milliohms to ohms, we should see about 1.089 ohms for the red bundle. So I'm going to run that test now. Keep in mind though, the instruments have a certain accuracy level, so you might see something keep a certain tolerance in mind. So I've got my multifunction tester here. I think if the cameras could zoom in, please advise if it is visible, because I can only see my slides here. So is it visible? Is the display visible? Wonderful. Now what I'm going to do is I'm going to go ahead and clamp the two ends. Nothing, no rocket science here. We're just taking into account a simple DC resistance. And we're just going to punch in the test button. And we get about 1.07, which is, like I said, within the tolerance of 1.089 ohms. Now, let's go ahead to our, sorry, one moment. Let's go ahead to our yellow bundle, which is our class 5. And I did the math again for you all. It's about 13.3 milliohms per meter. At 90 meters, when we do the unit conversion, we get about 1.197 ohms. So let's do the math. Let's run the actual test. And, sorry, one moment. I think we have some contact issue. Sorry?
If people, those who are standing there, if you can sit on the seats would be nice. We request you to please take your seats.
So let's run that test now. And we're getting around 1.23 ohms. Like I said, 1.197 is around 1.2, so well within the tolerance. Now I will show you something rather scary, which is what happens when I measure the resistance on the blue bundle. I went to an electrical wholesaler. I asked for a regular ISI marked 1.5 square mm wire, and I did not specify any brand name. I did not specify any quality, nothing like this. I said, give me the cheapest you've got. And it was a very reputable one. It is an ISI marked product, just so you know. Now, let's see what comes up. And just so you know, the next slide has a certain value I've written down for the coil resistance. If you mess with this wire, I got this from Mumbai, by the way, and you play around with it, the resistance changes quite significantly, because this is that poor in quality. And this is available in the market, by the way. Any guesses for what we'll get in terms of multiples? Times 1, times 1.5, 1.1. Any guesses? Sorry? Nothing. You already know. You guys already know the answer. So let's measure now. We get 2.1 ohms. So you see, from 1.089 to 2.1 ohms, we have almost a times 2 jump. And when I just got this, I actually measured 2.25. So when we do the math, we get that this has a resistance of 2.5 milliohms per meter. So this is double. Now, not only are you going to have energy wastage, the much bigger concern is, as per NEC, there are maximum loop impedance values that are specified, which means that, see, we've got overcurrent protection devices that have to disconnect in event of a fault. These require a minimum level of current to operate. The level of current is dependent on the impedance of the circuit. The impedance of the circuit is dependent on the source, so what the loop impedance is at the point of commencement of supply, and then your actual cables and conductors. And now, let's consider a situation. We have a lighting circuit with LED lights. We have a C10 MCB that we have. Assuming on an optimistic side, we have a source impedance of 0.35 ohms. Our maximum R1 plus R2, which is line plus neutral or line plus protective earth, has to be 1.18 ohms. Because the maximum is 1.53, so 1.53 minus 1.35 is 1.18 ohms. If R1 equals R2, because line and, let's say line and protective earth or line and neutral are the same, then we are limited to 0.59, yes, 0.59 ohms for the entire length. Now, the consequence of that is that for A, our red coil, we can only run a 48-meter circuit on a C10 MCB. For a B, which is our blue one, we can run 44, so there's an improvement there. But for C, we can only run 23 meters. So this is how drastic the actual effect is. Bear in mind again, B is not actually meant for fixed wiring. This is for control panel stuff. This is class 5. It is a fine stranded cable. It is only meant for use for appliance cords, flex cords, stuff like that. This is not for fixed wiring. Now I think on to you guys.
So, you see, majority of the wires sold in the market are unfortunately the blue one. We were doing we went to the market and we were just, checking in the market how this system works. So, we made some inquiries. I need 30,000 meters, 40,000 meters. Then the answer sometime from the shopkeeper is, which make you want and what price? And where do you want? Then I told, no, if I buy at the market price, let's say 900 rupees and you are ready to supply at 600 rupees, immediately I know that it's duplicate. And if I say that, if I'm asking them, no, I cannot carry it, if somebody catches, I'm in trouble. No, you tell me where it is required, we will deliver there. So free deliveries and all these facilities are there. The cost is half, resistance is also double, energy, you know what kind of safety situation we are going to end up. I would recommend that every project, please specify this particular resistance and tell the builder to have one of these meter and ask the people, somebody should measure the coils which is supplied and before using, you measure it. Then you will find out how much duplicate wires are there in the market. This is a serious concern. Before talking about fire, we should talk about these small installation problems. Let us not talk about big things. Net zero. What net zero? Your current is wasted here. Then we talk about net zero. First, let us fix these problems. Now, to fix this problem, people always ask, there is a rule, there is a regulation, there are so many standards, which one to use? Is always a question asked by the users to us. Now we have a new guide. I would like to ask Madam, can you explain what is the purpose of this particular guide?
Yeah, sure. Thank you so much. The standards actually give everything, like he's talking about the cables also, class 2, class 5. Class 5 copper cable should not be used in fixed installations, but they are available in the market. They are being used in fixed installations. Those are standards. The IS 694, which covers the wires for domestic cables for domestic wiring, very clearly says that only class 1 and 2 wires should be used for fixed installation, and class 5 is for flexible cables, for flexible purpose. But they are not being followed, and it is not being followed because generally the people are not aware, the users are not aware, and the contractors, they take advantage of that fact. Now coming to this IS 18732, as I already said earlier, that first and the foremost thing to actually do was to make people aware about the availability of the standards, that these standards are available. If we specifically talk about the electrical installations that we are doing right now, so these particular standards are available on the electrical installations and they should be used. Now that is the first step. Now once that is done, once the point is driven home that these standards are available and they should be used, the second step, the second question comes, how to use these standards. Because I agree that there are a number of standards available on electrical installations. They have all been compiled also in NEC, elaborated further, but then NEC itself is a very huge document, as already informed by Mr. Gopakumar. It is more than 700 pages, so not so easy for even the implementer, the professional, to understand, to go through it, and to implement each and every provision covered in these standards. So it could be due to various reasons. There can be due to lack of knowledge, due to misinterpretation of certain clauses, then which safety features, where to use, such type of misunderstandings can come up. So the felt was required to bring out a guide which guides people how to use the standards which are available on electrical installations. So this guide 18732, which has been recently published, it is basically, it gives a step-by-step guidance to the professionals, to the implementer, to understand and use the various clauses, sub-clauses, which are covered in IS 732, IS 3043, NEC, NBC. It gives all the details. There are tables here. I think Gopakumarji will give you the details. Tables are covered, which gives the full details. And it makes it very easy for people to understand these standards and put to use and without actually making mistakes. And this standard also very clearly gives a definition and explanation of the various categories: the developers, the builders, the architects, users, electrical consultants and electrical contractors, and their roles and responsibilities of each one of them. It is very clearly defined in this guide. So this is a very useful guide for the people to understand the standards which are available on the electrical installations and as well as the NEC. Thank you.
Yes, a lot of forms. Actually, this guide is very useful. It's a handy, it's a very simple document, only few, maybe about 20, 30 pages. You can go through it and you can very easily understand, which standard to be followed for a particular application and how it has to be done, and which clause of the standard is referring to this particular subject. So, very easy. Also, the standard explains building classification with respect to evacuation and the electrical installation. First time probably in a standard globally, this kind of, we have classified it based on the National Building Code building classification. Also the frequency of periodic verification, all these things are included, a very handy guide. Now in NEC, we have actually included some new protective device. The one is especially protection from electric shock. RCDs are sometimes required. There are different type of RCDs. There are new products such as AFDDs are recommended. Please note that it is not only in this NEC, it was there in the previous NEC as well. So we would like to hear from you, Dwivedi sir. What is your opinion on these devices?
Okay, let's talk about business in electrical safety. We have, potential business in electrical safety also. See, what is the cost of electrical in any project? It is not even 8 to 10% of total project cost, right? So if we can, as MEP consultants and as responsible people for electrical safety, push our clients to some extent to spend slightly more for having good electrical safety, it should be, it will be all welcomed by all of them if we explain them properly. Basically, these 4 types of MCBs are available, RCDs are available, electronics has gone into them also. They are capable of even analyzing current signatures of different faults. AFDDs can distinguish between series universal motor current sparking at its armature and physical sparking between 2 conductors. So such safety devices are available. The only thing what I feel is as you go on reducing MCB capacities, 2 amperes and 16 amperes, the availability becomes slightly, delayed deliveries are there. Something similar happens with these kinds also. Unless and until we start recommending them in a big way and use them in big way, it will be, they will not become popular. So provisions are available for better safety now, just like we were talking about IoT since yesterday. These are also kind of local IoT devices, I would say. They have electronic capabilities of analyzing the fault much earlier and extending the protection. Obviously, they will trip provided whatever Chris said doesn't happen on the field. So ultimately, the cable resistance also controls switching time of any switching device or a disconnecting device is equally important. So both these things, if we can take care of, then electrical safety at various level can definitely be implemented. AFDDs, I would request, you all can probably request a webinar from all 3 leading switchgear manufacturers. All of them they have now. I know actually few companies who have implemented it in bulk. People have bought 20,000 AFDDs for replacing all main MCBs in their establishments for imparting electrical safety. So things are happening, but they should happen even at ground level also. Just like NEC and all these codes cover larger installations. If frankly speaking, they don't cover only large installations, right? They are applicable even for a barber shop also, which I was explaining yesterday. So they can go even to that level and impart safeties. Fire can happen even in a hutment also. It will not happen only in hospitals and other things. So these things are now available, and what we can do tell this gathering is probably start using them in a bulk way, so that the effect can be.
Actually, RCDs, there are 4 types RCDs available. I am sure most of you are aware. Now, what is the written or what is included in NEC is Part 1, Section 10 included these devices. Extra, for example, type AC is for AC leakage, type A is for pulsating DC leakage, type F RCD is necessary for, say for example, inverter air conditioners or inverter refrigerators, inverter washing machines and so on. Also type B RCD is necessary for 3-phase variable frequency drives as well as for solar PV, rooftop solar PV where there is no simple separation. As I said, these are not new in the NEC, it was already existing, but this time since it is made mandatory, so these devices also may be required to fulfill the safety requirements. I have just put 2 photographs. One is the ABB, the normal RCD which doesn't have any special symbols. And the next one is type B. You can distinguish between different types with these symbols. Of course, availability is a question, but once when you start specifying, volumes will go up, prices will go down, then naturally, automatically the demand, there will be demand and people will stock these devices. At the moment, getting these devices are a little bit difficult. Type A, now the next point is type AC RCD, which is predominantly used in India. It is legally written in several nations not to use type AC RCD anymore. Because nowadays we have electronics everywhere. Even LED lights need a type A RCD. If you use a type AC RCD for a type A application, sometimes the AC RCD will be blind, so it won't work. So we have to select the appropriate device. This is one information. Then we also again go back to Krish about the selection of wires. Krish, in the NEC, always a debating subject. Why 1.5 square mm wire for lighting circuits and 2.5 wire for power circuits? This is, then people say, I will not use 1.5, I will use 0.75 or 0.25 or 0.1. Krish, can you throw some light on it?
Hello? Yeah, thank you. May I? Okay, so this table has had quite a bit of talk around it. I just want to make it clear, this is the minimum nominal CSA. What this means is that when you actually run your electrical design calculations, and if you get a smaller cross-sectional area, that smaller cross-sectional area cannot be used. This is the minimum. So, for instance, if it says 2.5 square mm for power circuits, what that is saying is that when I run the calculation, I'm going to show you how. If I get that, say 1.5 is acceptable, as per the calculation, it cannot be used. This table is not saying that for all lighting circuit 1.5 square mm, for all power circuits 2.5 square mm. This table is saying, taking into account your calculated values, the calculated values cannot be lesser than these values. That's all this is saying. You know, one of the biggest questions that we get asked is, this is a circuit, this is the MCB, what wire to use? And I say that there is no single answer to your question. It is a very situation and condition dependent question. So I'll show you what I mean. So as we know, NEC and IS 732, which is the code of practice for electrical installations in low voltage, go hand in hand. IS 732, if we look at clause 5.2.6 and clause 4.4.4, they tell us that, firstly, circuits shall be designed such that overloads of small overloads of long durations do not occur. And secondly, when we coordinate our conductors and our protective devices with our loads, certain things need to be taken into account. There is IB, IN, and IZ. IB is the design current. So, say I've got a 16 amp socket outlet, and I have got 6 socket outlets connected to one circuit. The expected load per socket outlet would be around 2 amps. So we do 2 amps into 6, that's 12 amps. IB is our design current. IB shall be lesser than or equal to IN, which is the nominal rating of the overcurrent protection device, in this case an MCB, which shall be lesser than or equal to IZ, which is the current carrying capacity of the conductors in continuous service. Now this in continuous service is an extremely important word. Let me tell you why. Say our manufacturer for our wonderful class 2 conductor tells us that this can handle 17 amps or 17.5 amps, whatever. The matter of the fact is this 17.5 amps only applies for the conditions in the table. For instance, if I have multiple cables grouped together in a single conduit or single enclosure, the ability of the cable to dissipate heat is greatly affected. Consequently, the cable cannot carry its full current carrying capacity. That is where duration comes in. So IZ, which is the value that we all talk about, has to be calculated as a function of the tabulated value IT and various rating factors. 732 recognizes CA, CG, CA, CF, CF. CG is for grouping, CA is for ambient temperature, CS is for soil thermal resistivity, and CF is for fusing. Now, let me tell you something. If I have a 10 ampere MCB, the moment the current crosses 10 ampere, it will not trip. There is something called I2, which is conventional tripping current. Conventional tripping current means, as per the product standard, once the current crosses a certain threshold, the product will trip in a specified conventional time. Generally speaking, for consumer installations, this is 1.45 times the nominal current and about 1 hour. So a C10 MCB will trip at 14.5 amps if it is 14.5 amps is present for a prolonged amount of time. That is 1 hour. And obviously, there is an associated maximum for loop impedance value. So now let's run this calculation. I have got 10 watt lights, I've got 20 lights, so 200 watt divided by 230, 0.87 amps. Because of the high starting currents, the manufacturer requires a C10 MCB. I'll specify that. Now, what cable do I use? Just because 1.5 square amp can take 17.5 amps and 2.5 square amp can take 24 amps does not mean it automatically complies. I will have to derate. Let us consider that there are 3 circuits together and the ambient temperature is 40 degrees. The 3 circuits together require a deration factor of 0.7 and the ambient temperature correction requires a deration factor of 0.87. Therefore, when we correct, we get the actual tabulated 24 amps for a 2.5 square mm can only use 14.61 amps in this specific case. Very important distinction here. Then for IZ, for a 1.5 square mm, 17.5 amps, same duration factors, we only get 10.56 amps. The point I'm trying to illustrate here, and this is very, very appropriate with, this is very relevant for power sockets for instance, is that often consultants, specifiers, electricians as well, they say, load itna hai, cable isse zyada de denge. And MCB load se zyada hona chahiye. Now let me give you a classic example. I was in Hyderabad and there was a wonderful 4-story building that I was looking at. It was a private residence, highly luxurious, everything was very well done. They have a demand of around 100 amps per phase and the cables coming in are 25 square mm. You will not believe what the MCCB was rated for. It was rated for 630 amperes and it had a times 10 overcurrent release. Therefore, it would have tripped when 6,300 amperes go through that particular cable. So now tell me, if I thought load 100 ampere hai, cable 25 square mm, satisfied. MCB will just put higher than the load current. We'll leave enough spare capacity. What has happened and what has gone terribly wrong is, if there is a short circuit, firstly our loop impedance, our minimum loop impedance requirements will be so low, we will never meet them. So when a short circuit happens, nothing will trip. Eventually something will burn, melt, fire will happen, people will die. In an overload situation, the same thing will happen because 630 amperes compared to 100 amperes is a massive difference. This I2 value it's not going to be taken into consideration. Anyways, I think the bell has gone off, so I will. Okay. So anyways, the point I'm trying to illustrate here, sorry, is that it's very important for this coordination to happen, and the coordination is as per the clauses in the standard. As consultants, we need to refer to these standards and we need to verify. Now I'll give you a classic example. If you go on site and you see somebody has put a socket circuit, very often I see a socket and lighting circuit clubbed together, 20 ampere C curve MCB, then what is going to happen is, firstly, the sockets are going to be wired in 2.5 square mm and the lighting is going to be wired in 1.5 square mm. But it's protected by the same C20 MCB. In this case, when there is a short circuit in the lighting circuit, the impedances are going to be so high that the minimum loop impedance cannot be met, and therefore we are going to have a fire. When we keep saying fire due to short circuit, fire due to short circuit, fire due to short circuit, as Mr. Gopakumar has said, it is not fire due to short circuits. Short circuits are, in a sense, manageable events in electrical installations. It is fire due to non-disconnection of protective device. And that is purely because of A, poor design, and if the design is done properly, poor workmanship. Please keep this in mind. It is not fire due to short circuit, it is fire due to non-disconnection of protective device, and non-disconnection of protective device will only happen when design is not done properly. And in the National Electrical Code of India, there is a form where 3 signatures are required: for design, for construction, and for verification. As a consultant, we have to sign the for design part. If a fire happens, if there is an incident where somebody is injured, who is going to be responsible? Whose signature is on there? It's our signature on there. It's us consultants. So as consultants, I would say it is our duty, not only in the interest of public safety, but in the interest of self-preservation, to please follow these standards. Thank you.
Thanks, Krish. It was a nice explanation, but please note that the size of the wire is the minimum. You cannot go below that. If you are going below that, your building is not in compliance with NEC. Very simple conclusion. Actually, if we look at the construction sector, I am sure the organizers will give us 2-3 more minutes. We also wanted to take a few questions. I don't know whether this is allowed or not. Now, if we look at the actual way the construction is going on, recently I came across a question from Mumbai. Nowadays, sometimes the earth electrodes in soil, which is connected to the structural steel, we are supposed to use copper or stainless steel, which is written very clearly in the standard. Somebody wanted to use a rebar with a paint in the soil. It's a big, the cost of each apartment is probably running into few crores, and the builder wanted to put a painted rebar in soil. This is the situation. So, as I said, the safety culture is not existing, but NEC is going to change the situation. A lot of changes are going to come. We can explain these changes probably 2-3 days. Hundreds of changes are required. So finally, we would like to conclude. Probably if you have any questions, and if the organizers, okay, 2 questions are allowed. Yeah. 1, 2.
Hello, I'm Dharmendra Yadav from Krishna Engineering Services. I have 2 questions. One with Mr. Chris. The 3 color bias bundles you have on the table, have you measured the actual cross section these are having? First question.
See, we have not measured the actual cross-section area. That would be rather difficult, because the thing is the copper is quite malleable as well, right? So, but if you would like to come, we can keep this if the organizers permit.
Actually, we wanted to keep the table somewhere outside so that you can come and you can touch it, feel it, and test it.
No,
then you can see the values of...
Why I'm asking this question, because the IS says 1.5, 2.5, but actual in the market practice, and all of even leading manufacturers also, they are not making the exact cross-section area. I myself tested 1.5 square with the leading manufacturer, I'm not naming them, having 1.2 or 1.3. And this all the manufacturers are following, because they give the argument that the IS specifies the impedance of conductor, whereas it says that cross-sectional area of 1.5, this can have this much specific resistance. So this question to even BIS team also, Preeti ma'am also, what BIS says clearly, if 1 point say it has to be 1.5, it cannot be lesser than that.
Please make a,
The
sorry.
easiest way is measure the resistance, all the problems of size, whether it is over or under, things will be very clear. Resistance matters.
And if you have done it, please make a complaint on the BIS Care app, like, because there's a CML number, there is a CML number printed on this, like
I
Ms.
also
Preeti
request
said.
you also please check it, whatever you have, the actual cross-section, yeah, this won't be exact 1.5.
I mean, I don't doubt it, but at the end of the day, resistance is the key parameter that we want to look at. But sure.
But what is the significance of specifying the cross-sectional area? If it is not...
Sir, then, as you rightly said, cross-sectional area, you cannot really measure. The easiest measuring factor is the resistance of the coil. You know that it's 90 meters. 90 meters is supposed to give X value. You just measure it. And then you know very well whether it is undersized or oversized.
No, if
The whole subject is
if the
closed.
difference in impedance is almost double, so naturally the cross-sectional area is also,
now in this
and the
case-
impurity also, both of factors
in
are
this
there.
Case, the blue color wire, it's a cheap wire. In the sense, it's a duplicate wire. Or more than 50% of the wires which is sold in the market are of this category. Not the color, but this kind of duplicate wire. That is the point which we wanted to highlight. Thank you very much for the
Apart
question.
from
Thank you.
cross-section, it could be purity of the copper.
Both
Recycled
the
copper
factors
when they
put together.
use these things
Purity is also checked. That requirement is also given in the standard. Then the copper wire requirement is also the dia requirement in case of class 2 and class 5, or the number of wires required. That requirement is also given in the standard. IS 8130 specifies both of them. But of course, measurement of cross-sectional area is not there.
Because the thing is that cross-sectional area has now become conventional. The primary factor, even in the standard, if you look at 60228 and 8130, is resistance. I understand that the cross-sectional area could be one contributing factor, but like Mr. Duveri said, it is highly likely, especially because when this wire was moved, the resistance varied a lot, that this is just impure copper, probably some adulterants, and the strands are so brittle that as you move them, they make and break contact. So I would still, in my opinion, my professional opinion is resistance, and that's what the standard says.
Measurement of resistance will take care of rho as well.
Yes.
L and A probably are known. So L and A rather they have declared. 90 meters they have declared, area also they have declared. Measurement of resistance will tell you what is rho.
No, but
There
I have
could be
one
some
more
issues
question.
with
Like
that
if you're saying ICE says 1.5 kΩ and this
Sir,
much
sir,
impedance,
it would be better we can take this question offline. There was one more question somebody tried asking. Yeah.
okay, thank you. Thank you very much.
Thank you very much. We will be keeping these materials outside. Probably we are also there. We can have a discussion later. Thank you. Mike, please.
Very good morning, CP Singh from KEI Industries. So not a question, basically I was enthralled by the technical presentation being done by the panel. One curious question came to my mind. I saw along with RCD there was one AFDD, probably arc fault detection device. Is it right?
Yes, AFDD is arc fault detection device.
I was trying to
Basically
understand.
arc fault detection devices which are supposed to be used with last mile smaller circuits. The LED on that AFDD will have 3 different colors. It will tell you whether it is tripping because of overload, short circuit or sparking. So in large office areas, it becomes very easy to identify, which circuit is getting tripped because of what. And that's the reason they are classified separately compared to MCB. They have some microprocessor based circuits inside which monitor current signatures of these 3 different faults.
Is
So-
it as incomer or you are saying different circuit wise?
Yeah, so
Actually, you
Main
cannot
incomer
use
of-
it.
main
You cannot use
incomer
it in all the
of LDB
circuits.
probably you can fix that so that it can distinguish between LDBs and LDBs what kind
so-
of fault it is.
So see, when we talk about AFDDs, like Mr. Duveri said, these are last mile circuits. These are required for every final circuit. This is very important because in an AFDD, when it detects a fault, it will disconnect the fault, an arc fault, either a series arc fault or a parallel arc fault. And these have to be connected on the final circuit. So if I have a house, say a room, I have got one air conditioning circuit, one socket circuit, one lighting circuit, and say one water heater circuit. With the exception of the lighting circuit, because the load is too small for the AFDD to actually detect any arcs in that load, all these circuits need protected by individual AFDDs, and AFDD is covered by the standard IEC 62606. There's also corresponding IS standard. Generally in the market, what you should use is a combined AFDD RCBO unit complying with IEC 61009-1 and 62606. These are actually supplied for every final circuit. So we're talking about 4 AFDDs for a room. Yes, this is going to be expensive.
I'm little more curious, anyway, we'll have one-to-one discussion, because typically what happens, even RCCBs or RCBOs are avoided, you know, because of lack of awareness, knowledge, especially at the ground level by the electricians. So I'm very curious, this AFDD coming into picture, if the installations are not properly done, you know, in all kind of buildings, how it is going to, but let us not take the time of the whole audience over here.
Yes,
We can have-
as typical auditors, what we find is generally RCBOs and all are bypassed because they trip spuriously. That's what the end user feels. If you use a wrong type of RCBO or RCD in any circuit, definitely it will trip. So some, you know, knowledge sharing and training also should be imparted for that. Products are available now. They will be, I mean, cost again has to be compared with the risks which we are taking, right? In a house where you are thinking about a AFDD, a single room might have gadgets worth more than 2-3 lakhs. So even property loss is also there, apart from life.
So that is, we go to the conclusion.
Just one minute, yeah.
Yeah, the last question.
Balachandran from RR Kabul. Madam, this is to you. You know, you mentioned about the code taking about 40 years. Now it is getting some teeth, becoming mandatory. But still, I think from the explanation given by Krish and Gopa also, the basic fundamental problem lies in what we call as being sacrosanct, IS 694, class 2 and class 5. The problem still lies with BIS. We have been talking about this for the last 20 years. We have brought it to your notice. CEA, luckily, through IEEMA, 2 QCOs have come, both for FS and DC solar. Why can't we do it for IS 694 where end use is specified, especially for class 2 and class 5? We have similar examples where the footwear industry, through BIS, they came up with their arm saying that we need time, but ultimately footwear industry complied with your QCO. So why don't we do for such a fundamental product, which means almost 48% from Gopa's statistics, it shows that it is the problem lies on the LV side. And LV side, the entire population is not knowledgeable. Unless you make it very strict, mandatory that class 2 and class 5, you specify the end use.
No, it is there. Actually, in IS 694, it is very clearly mentioned that IS 8130, it refers to 8130 for the conductor, and the 8130 very clearly says that for fixed installation, you have to use class 1 or class 2 conductors only, and not class 5. Class 5 is for flexible applications.
Exactly, madam, but the problem lies with class 5 interpretation.
No, but then this is being misinterpreted and misguided by people.
That's precisely what I'm saying.
A common man in the field will not know the difference between class 5 and class 2. So it is actually the responsibility of the manufacturers not to misinterpret the standard and not to misuse it actually. The standards are okay. There is nothing wrong in the standard. You see, 694 is in existence for 50 years, I don't know, when it was first published, way back in the 70s or before that.
60s,
and this problem of class 5 coming up as fixed wiring cables has come up only a few years back. Before that, we used to have only class 2 conductors for fixed installation. There never used to be any class 5 conductors for fixed installation. So why it has come? 694 has not come now. 694 has been in use for so many years, and it has been mandatory for so many years now. It is not today, it is a mandatory standard for many years now. So
true, madam.
There is somewhere some responsibilities should be fixed even in the field, even to the manufacturers. You see, BIS is doing their job. But if people don't interpret it properly, misinterpret or misuse it, and the exact information is not conveyed, then things will happen.
True, madam. This,
Application, no standard is
No, no.
application based.
Absolutely,
basically.
there's no issue. After 2009, this dilution has happened.
Yeah, but why?
Yes, so
694
2009.
was there before that also.
Yeah, 694 was there, even class 2 was there. But here we have the entire fraternity sitting with us. They can vouch for it after 2009, where both these conductors were interchanged. Now, class 5 is being used freely instead of class 2.
That is not correct, no? It is not correct.
Exactly.
The
no, but
standards are also saying it is not correct. The standards are very clearly saying that for fixed installation you have to use only 1 and 2. But
Unless-
how BIS can bring it to the notice of the people in the field? You tell me, we are there, the standard is there. Okay? They don't, the user doesn't read the standard. He will ask the contractor कि मुझे घर बनाना है, building में wire चाहिए. अब contractor या फिर जो भी है, he will bring a class 5 conductor cable. The user will not know that it is not the correct cable.
yes, madam, all we request is a small modification in 694 which says that, so that it becomes very clear for everyone.
I think this was this comment has
Sir,
already
there is
come
a-
in our office. It was also put up to the committee, but again it was felt that already the standard is saying this. You feel if we add a one line, will it make a difference? No, because the people again are not reading the standards. People who are in the
Really
users
sorry to
don't know.
interrupt you, ma'am, but then if we look at the international standard, then there is the marking nomenclature given called like HO7, VU or VR or VK, which specifies that K means class 5, R is class 2 and U is for solid conductor. So that nomenclature comes on the cable.
No, the class 1 and class 5 is mentioned in that marking clause.
I
na?
totally
there.
agree with you, ma'am. But the print matter of the cable doesn't have the mention of class 5 or class 2 as internationally or
Thank you,
globally
thank you,
accepted.
On the-
Nitik.
on the
We
cable
will-
itself.
we will
Yeah,
we will
if that
discuss
is
this
just
in detail.
undertaken,
We
then
are-
it will clarify to all the manufacturer as well as the end user that what is to be used.
No,
That
of
is just a
course.
humble suggestion.
Please note that the users have been confused in this
Yeah.
particular subject. Class 2 or class 1, class 2 is mandatorily required. This is the first step. Maybe before 2005, the wires were proper, but 2005 to 23, the class 2 wires has been changed to class 5. Now, most of the market, only class 5 wires are available. That means class 2 is very rarely available. Availability is a problem. First of all, the manufacturers, all the manufacturers, reputed manufacturers to come up, and you have to make the class 2 wire available in the market. Because if I wanted to buy, for example, in a program in Nagpur, we wanted to buy a copper class 2 wire. It was not available. So manufacturers also should step up. And from our side, we are making a very tricky method. We are writing to the electrical inspectorate to make class 2 mandatory. Thank you very much. Yes, this would end the session. Thank you.